And welcome to day 2 of the webinar series on reducing roadway departure crashes. Once again, looking at the handout section of the GoToWebinar panel, please note that a copy of today's presentation is available for reference. Also, please feel free to use the questions box today to submit any questions you might have. So with that, we will proceed with day 2. Good morning, Ron.
Good morning, Mike. Thank you. Good morning, everyone. Welcome back for day 2 of reducing roadway departure crashes. Yesterday, we talked about kind of introduction and background. We looked at some implementation strategies. And I believe when we finished up, we were talking about signing and marking methods to keep drivers on the roadway. And we have a little more to do on that topic today to finish up, and then we'll move on into some geometric and pavement methods to keep vehicles on the roadway. So let's proceed. This slide, it has a couple asterisks around it. That's because if any of you are following the handout, this slide is not in the handout. I just added this morning based on discussion yesterday. I wanted to say a little bit more about chevrons. We had a question or a comment, I think late during the class yesterday, about with the LEDs lights on the chevrons, it does require an experimentation protocol through Federal Highway Administration. And I believe I said no, it did not. And here's the source of that. In section 2C.08, paragraph 7, the MUTCD says LEDs may be used to enhance the conspicuity of chevron alignment signs. So they are an option. There's no requirement to use them, but they can be used. And as I was reading that section, I thought about a couple other things that maybe we should mention, because I do see these two items maybe out of compliance as I travel the country. The first standard that we'll talk about here is, notice the manual says chevron alignment signs shall not be used to mark obstructions within or adjacent to the roadway, including the beginning of guardrails or barriers, as this is the function of an object marker. And I see chevrons being used in this application. I'll say not uncommonly, and it's one of the things sometimes people who have taken this class before, if they see something unusual, they'll email a photo to me and ask what I think of it. And just this year, a few people have sent me photos of chevrons, thinking of one on an interstate exit ramp in the southeastern United States, where chevrons are used kind of at that split at the beginning of a guardrail, where really they should be using an object marker. So something to keep in mind. And then the other thing that also I see sometimes does not comply with the manual is the last item here, that chevron alignment signs directing traffic to the right shall not be used in the central island of a roundabout or a neighborhood traffic circle. As some of you may know, I teach a traffic calming class, and I believe I'm going to have to go back and look at that, because I believe I have a few slides in that presentation that show chevrons being used in the central island. And according to the manual, they shall not be used. It's a standard in that application. So I just wanted to add that based on the discussion yesterday. Now we'll catch up. I think the last thing we did was I showed a short video on the dynamic curve warning system using the LEDs and the chevrons. This was going to be my next slide. And this shows the CMF values for the speed feedback signing for curves, which I also presented toward the end of class yesterday. And you can see data here for two types of crashes: total crashes and single vehicle crashes in one or both directions. And you see the CMFs are between 0.93 and 0.5. So that's what, 5 to 7% crash reduction factors. Here's an example Signing for horizontal curves. Talked about this yesterday. These photographs show portions of US Route 2 south of Glacier National Park in northern Montana. The lower left image, get my cursor here, the lower left image here, this is the approach to the curve, which you see in the upper right. The ADT is about 5,500 vehicles per day, and the crash experience is about 5 crashes per year. And you can see from the roadside memorial that a number of those have been fatal crashes. If you look at the curve itself here in the background where my cursor is, I think you can see there's actually concrete barriers on both sides of the roadway. And I should note that on the left, our left side of the roadway, there is a significant elevation difference there. It's almost a vertical slope going down to, I think it's the Flathead River, and to a railroad line, railroad track. And so the barriers are believed to prevent vehicles from getting onto that steep slope. But you can see there are chevrons, fairly closely spaced. You can also see the right arrow here. And notice one thing about the devices are quite high in terms of elevation or distance above the roadway. And that is probably due to the heavy snow that falls in that area, both fallen snow and then the piles of plowed snow. So looking at this, the question I have for you all, you can see there are obviously some signing and marking already, but any additional signing or marking countermeasures that you would apply here, you can feel free to type your suggestions in the chat and Mike will share those with us. But again, the image on the left is the approach to the curve that you see on the right-hand side of the screen. So any additional signing or marking countermeasures anybody can think of or would apply there?
Thanks, Ron. We have people typing comments. Advance warning sign, curve ahead sign with advisory plaque if applicable. Check the retroreflectivity, raised pavement markings, curve ahead with advisory speed. Reduction in speed limit, wider striping, reduced speed, advanced curve sign. So these are some of the comments.
Yeah, good ideas, great ideas. In fact, yeah, note this is what struck me too. Notice there's no curve warning sign, which many of you commented on. And I think it would be good to have a, in fact, necessary to have a curve warning sign with an advisory speed plaque underneath it. I think that would be appropriate. So good work on that. And I also appreciated the comment about, well, the wider edge lines. As an older driver myself, I'm a fan of the wider edge lines, but also I appreciate the comment about checking the retroreflectivity, because there are a number of devices there that looks like the object marker on the symbol on the end of the guardrail, the chevrons, the arrow, and it would be good to check what those are like at night. How bright are they at night? So that was a good comment about the retroreflectivity. So thank you all for your responses there. And if I remember from yesterday, I think the CRF for a curve warning sign, I think is 30%, I believe, because I think the CMF was 0.7, so the CRF would be 30%. We also talked about enhancing visibility and conspicuity of signs. Here's another approach that has been used. Notice kind of maybe oversizing the sign, in this case an exit ramp sign a little bit, but also adding the yellow and black diagonal striping to maybe attract the attention of drivers. And we were talking about nighttime driving. There was the comment about retroreflectivity of those devices at the curve there in Montana. And if you think about daytime driving, which we saw in that Montana example as well, there's many cues available to drivers. And I like to talk about two different types of cues that drivers rely on. Drivers, of course, rely on the formal cues or formal information that we in the road business install on the roadway for safety and to communicate with drivers. So in the daytime image you see here, we can see, of course, the white edge line. That's a formal communication mechanism. It's in the MUTCD. It's applied by the road agency to help communicate with drivers, help delineate the road alignment, the edge of the roadway. So that's a formal information device. There's probably a double yellow center line. You sort of see evidence of it here, but it's not that visible. It maybe has worn out. But then that would be also another formal device. But then also notice there's, in this view, three chevrons. These are also formal mechanisms installed by the road agency to communicate to the motorist as far as the alignment of the curve. And I think if you look closely right here under this chevron on the right, it looks like a little post-mounted delineator with a kind of a button type delineator at the top. So those are all formal mechanisms, formal cues installed by the road agency. But I also like to say drivers also rely on informal cues to help them navigate the roadway. So in this example, the guardrail would be an informal cue. The guardrail is a safety feature. We'll talk more about it probably tomorrow, but it's not intended as a traffic control device in the sense of the chevrons or the edge lines. But would you agree, given its location, it also sort of lets the drivers know that this roadway doesn't go straight ahead. It, in this case, turns to the left. So that I'd call that an informal device. Also, this hillside or mountainside in the background, obviously not a traffic control device or anything like that, but it is an informal cue, again, that tells the driver this roadway does not go straight ahead and we're going to have to turn to the right or left, or in this case, the left. So you can see the combination of formal and informal cues make the driving task relatively easy. But at night, look what happens. Those informal cues disappear, and really the only information that's available to the motorist is the information from those formal devices. The chevrons, we can see the little button delineator here, and this photo is apparently not exactly the same view as the daytime photo. It looks like there's a yellow, maybe post-mounted delineator here in the lower right. But no, even the white edge line is not visible in this image. And so that the key thing to get from this is that it's the retroreflectivity, the brightness that the signs have, that provides that nighttime guidance, nighttime communication with motorists. So retroreflectivity is important. Number of benefits, not only improved safety, crash reduction, but in terms of drivers, improved traffic operations, and particularly for older drivers, it helps them function more safely and more efficiently on the roadway. With respect to signs, retroreflectivity, a number of agencies are using the fluorescent yellow color, not only for chevrons, as you see here, but for signs as well. And I think this photo shows kind of the benefit of using the fluorescent versus the standard yellow. Notice every other chevron is a standard yellow. And notice in this low light condition here, I don't know if this is dusk or dawn, but notice that the fluorescent yellow, and I'm speaking of fluorescent yellow, not fluorescent yellow green. This is just fluorescent yellow. But notice how it is more conspicuous. And as an older driver, again, I appreciate that. Here where I am in West Virginia, our DOT for a number of years now has been using a lot of fluorescent yellow color, not only for chevrons, but for warning signs generally. And I really like it. I think it does make the signs more conspicuous, especially during low light conditions. There has been some research into the crash reduction effectiveness of fluorescent sheeting. And you can see here from the CMF clearinghouse, you can see some results. The CMFs vary from 0.65 to 0.82, meaning crash reduction factors from 18% to 35% under a variety of different rural sort of conditions, different crash severities, and different crash types that they're looking at. Another thing that can be done to enhance the visibility of signs, warning devices, regulatory devices, is the post delineation. As you see here, notice these retroreflective plastic sleeves that can be placed on the post, on the sign post, to enhance the visibility, make the device more conspicuous. The color must match the color of the device itself. So for example, for a stop sign, you need to have a red sleeve or red plastic on the stop sign post. And there can be no, according to the manual, there can be no word messages or that sort of thing on that post, just simply a solid color. It does need to be retroreflective, but since it's an enhancement rather than an actual traffic control device, those sleeves do not need to meet the minimum retroreflectivity requirements. But of course, the chevrons themselves would need to meet the minimum retroreflectivity requirements. With chevrons, it's important, well, any sign really, but especially chevrons, important to orient the chevron to approaching traffic. Like you see here. And I like to recommend nighttime inspections periodically, because as you see here, there are some signs of concern out there due to weathering or damage or other sorts of deterioration. There may be signs, portions of signs or signs themselves that are not clearly visible to motorists at night. And even if you're using a sign management method for maintaining sign retroreflectivity, I think these examples illustrate why it's important to you still need to do, I think, those nighttime inspections, because things like this happen. I mean, even if you're using the retroreflectometer method, depending where your agency's taking the measurements, you may miss some of these areas of concern here, like shown in these images. And just signs generally, here are a variety of different signs of concern that are out on the roadway. Maybe we start in the upper left here. Stop ahead sign with a driveways sign underneath it. And in my opinion, this is not compliant with the MUTCD. It appears this agency is trying to maybe provide two warnings on one support, apparently warning of driveways, maybe hidden driveways ahead, but the MUTCD does not allow for that. Also, just this rectangular plaque is not considered a warning. You'd need to have a yellow and black diamond-shaped sign. So to me, a plaque that would be allowable under this sign would be maybe the distance to the stop ahead or to the stop sign itself. Center top here, notice we have a turn sign, and the plaque under that should be the advisory speed of 30 miles per hour or below. I don't believe slow is an appropriate advisory plaque that you would find in the MUTCD. It should be an advisory speed plaque under that sign. And of course, here in the upper right, we have a yield sign, red and white sign that is pretty much faded to all white. Certainly does not comply with the manual. But one thing that does help is notice it has the unique triangular shape, even though the message is gone. But this sign should be, in my opinion, replaced relatively quickly. Then down here in the lower left, looks like a work area. The road is closed. And here's a black and white sign advising of sharp bend or sharp curve in the roadway. Of course, warning signs in work areas like this should be orange and black, and probably a symbolic turn sign, maybe with an advisory speed would be appropriate, but black and white is not appropriate for warning signs. How about the center bottom here? One stop sign on top of the other. I think this agency was trying to highlight or emphasize the stop condition, but this is not the way to do it. This is not permissible under the MUTCD. If you want to use two signs, and we talked about this yesterday for warning signs, to double up the signs, there needs to be a stop sign on the right, and you could put another stop sign on the left side of the road. That would be an appropriate way to double up the signs. Another thing that could be done to attract the attention of motorists would be to make an oversized stop sign, a larger sign than the conventional sign. Another thing that could be done would be to attach the red plastic retroreflective sleeve that I talked about a few minutes ago. You could attach that to the support for the stop sign to help make it more visible. You could attach a red flashing light at the top of the stop sign. You could use red LED lights around the perimeter of the stop sign, that flash. Those are all appropriate ways to, or appropriate enhancements to attract attention or make the stop sign more conspicuous. But what you see here is not. And then our last one here on the lower right, the sign looks okay. My concern here is, you recall, I think we talked about sign supports need to be crash worthy. This large concrete block here would not be a crash worthy support. So the issue here is not so much with the design of the sign itself or the message or the color, but with the non-crash worthy support for that sign. Sign maintenance is critical. We can have good sheeting, good signs, but there could be various things that could limit their visibility daytime or nighttime. And notice this example, some chevrons around a curve. Notice in the daytime we have the formal and informal cues. So in a way you could say the chevrons maybe even are redundant during the daytime because the driver can see the alignment of the roadway. But notice at night those visual cues, the informal cues, disappear, and the drivers rely on the chevrons to navigate the roadways. Apparently there's no pavement markings. And there's four chevrons here. They were all installed on the same date. They all consist of the same type and grade of sign sheeting, so they should have similar brightness. These two, you can see, of course, do, but notice this sign is basically a dead sign. It's not really showing up for the driver. And if you look closely, notice it looks like this sign is twisted a little bit and bent, and so it doesn't catch the headlight beam, and so it's not visible to motorists. So sign maintenance, just in terms of the positioning and proper alignment of the sign, is important. As is vegetation. Vegetation in many parts of the country in warmer months can grow rapidly, can block the vision or the view of signs of various types along the roadway. So periodic routine maintenance in terms of vegetation trimming or brush cutting or those sorts of things are also a part of making sure that signs are visible to motorists. So we've talked about a number of different things here, and we have some review questions. And again, you can respond in the chat, and Mike will share some of the responses. But here we have a multiple choice question. Which of the following is true regarding the MUTCD requirements for signing and marking? The MUTCD requires edge lines on all roads. That's A. B is, in some cases, it may be appropriate to use signing and marking even if not required by the MUTCD. C is markings that must be visible at night are required to be retroreflective. And D, at all curves where an advance warning sign is required, chevrons are also required. Any thoughts on that? Which of those, or which one of those, or maybe more than one answer, is true regarding the MUTCD requirements for signing and marking?
Thanks, Ron. We have people typing comments, and several folks have said B and C, and there are a variety of other combinations, but quite a few are saying B and C.
Okay, I would agree with that. And of course, A, we talked yesterday about the specific requirements or conditions where edge lines must be used or are recommended to be used, but the MUTCD does not require edge lines on all roadways. So that's not true. B, yes, that's correct response. Those of you who responded, in cases it may be appropriate to use signing and marking even if not required by the MUTCD, using engineering judgment. So B is true, and C, markings that must be visible at night are required to be retroreflective, and that is correct. That's in the manual. For example, crosswalk markings and such must be visible. So C is correct. D is not correct. Not lower speed conditions. You may have an advance warning sign required, but the MUTCD does not require chevrons in that instance. So the correct response would be B and C, as many of you responded. Thank you for that. Another review question. Which of these are enhancements that can be made to improve safety? A is doubling up advance warning signs. B, use fluorescent yellow prismatic sheeting. C, use a red background on warning signs. D, wider edge lines. E, placing chevrons on both sides of the road. And F, using delineators in curves where chevrons are not required. So what do you think? Which of those are enhancements that can be made to improve safety?
All right, we have comments already. A few folks are saying A, B, D, and F. We have one who says A through F. B, D, F, A, B, D, and F. And several more A, B, D, F, E.
Okay, getting good responses.
Okay,
Yeah.
yep, thanks.
Yeah, thanks, everyone. Thanks, Mike. Yeah, I would say A, B, D, and F would be the correct responses. We can double up advance warning signs by doubling up, I mean on the right and left side of the roadway. That is permissible under the MUTCD, and that is a way to enhance the message or the visibility of warning signs. B, we talked about fluorescent yellow sheeting. That is another method that could be used. C is not, because it is not appropriate to use a red background on warning signs. The red background is for regulatory signs. D is correct. We can use wider edge lines. E is not correct. The MUTCD says that chevrons are to be placed on the outside of the curve, so it's not correct to use them on both sides of the road. And where chevrons are not required, we can use delineators, post-mounted delineators, or flexible delineators in curves where the chevrons are not required. So the ones that are not appropriate are using the red background, C and E, placing chevrons on both sides of the road. Thank you all. Good job on that. So we have talked here in part 3 about methods for reducing the potential for vehicles to leave the roadway, and we've tried to focus on low cost, kind of short-term types of fixes. Are there any questions or comments or concerns about any of that material?
Thanks, Ron. We do have a few comments and questions. Sandra says she thinks she remembers a study years ago that reviewed how drivers look for cues, and they found that some are mostly sign drivers and some are more pavement drivers, basically looking at different places for information. So she's wondering if you could comment on this concept and the importance of both the signings and the markings.
Yeah, great comment. And yeah, I think I recall reading that too, but you're right, it probably was some time ago. I like to think about, and of course, where appropriate, it's not always appropriate, but where appropriate, I'm a fan of using both the signing and the pavement markings. And as many of you have probably seen, at least I've noticed it in my driving, more and more agencies are using, for example, I believe they're thermoplastic, the route markers like the interstate shield with the route number or the US route with the shield with the route numbers. In addition to the signing along the road, putting that in the roadway itself where it's kind of directly in the driver's field of view. They don't have to move their eyes from side to side. Or I think yesterday I mentioned Pennsylvania developing and using the advanced curve warning marking to supplement the sign. So they use both the sign and the pavement marking. And I have seen, I think it's mainly been out west, but I think I have seen, it seems to be more and more common where some agencies actually will, in addition to the signing, they'll post the speed limit, not posted, but they'll mark it on the pavement as a pavement marking, which I believe is also consistent with what we're talking about of having the sign and then the pavement marking. So yeah, I think where we can do that, where it's appropriate, that is definitely something to think about. And I think drivers appreciate that as well.
Thanks, Ron. We have comments from Kessa. With regard to sign retroreflectivity, we had a few slides showing fluorescent versions of certain colors. And she's wondering if the fluorescent color is so much more visible than the standard color. She's wondering why some agencies would buy the standard signs. She's wondering if that's mainly a cost issue.
That's a great question. I've sort of wondered that myself. And my thinking is it probably is a cost issue. But like I mentioned before, as an older driver, I'm a fan of the fluorescent yellow. I think it makes the signs more conspicuous during low light type conditions.
Thanks. Follow-up comment from Sandra. She says regarding road tattoos, be careful. They can be slippery for motorcycles if solid filled in.
Well, that's a great comment. Yeah, thank you, Sandra. I appreciate that. Yeah, that is a good warning, good advice, I think, for all of us. So thank you.
Question from Stephanie. She's saying, with regard to damaged or knocked down signs for after hours, weekends, etc., what should be the recommended repair and replacement time, response time for those types of issues?
Great question. And I'm not trying to evade your question or be a smart aleck, but I will say it probably depends. For example, if the sign is It depends on the type of sign, for example. Is it a safety critical sign like a stop sign or wrong way sign, that sort of thing? Those to me would have a higher priority than, say, an information or guide type sign. And it's going to depend also sort of where the sign is, on what maybe functional class of road, what type of area. Is it in a commercial area which has significant traffic versus a remote rural area where there may be lower traffic volumes, even in terms of even someone reporting the sign. I think the main thing would be is for the agency to have some sort of protocol for dealing with those situations, depending on the type of sign, the nature of the roadway in terms of functional class and speed and volume and those sorts of things. And may also probably involve, for example, other maybe agencies like law enforcement, perhaps even EMS or that sort of thing, to kind of get their help maybe in reporting some of these damaged or knocked down signs. So to me, the key thing would be to set up a protocol for your agency for these conditions. For example, what will we do with stop signs? And in terms of getting that sign replaced or a temporary sign up, or have law enforcement at the intersection if it's a stop sign, or those types of things. And that will vary from agency to agency depending on the size of the agency. And I'm speaking there in terms of sort of geographic coverage. The smaller areas versus larger areas may have different response times. But good question.
Yeah, thanks, Ron. Stephanie has added, this is why she's asking the questions, as they are trying to develop their protocol and procedure. So thank you for your comments.
Yeah, and I think, Mike, you can correct me, but I think in January, I think I'm doing the tort liability risk management class. And
yes,
we will get into those sorts of questions there more from which is probably what Stephanie's referring to. What happens if there is a crash and someone's killed or injured, and then we have a lawsuit against the county or the city or the town or whatever it is. So stay tuned for Mike can give more information on that, but we will sort of get into that topic as well in the tort liability class next month.
yes. All right. Thanks, Ron. Let's see. One more from Sandra. When she was at a rural county engineer's office, they would do immediate call outs if there was a stop sign issue.
Yeah, I would agree. That stop sign should be, as I said, I called them safety critical signs. So yeah, stop signs should be the top priority to get that addressed in some fashion, even if it's temporary until the permanent sign can be installed. I would agree with that.
All right, thanks, Ron. Those are all the questions at this time.
Great, thanks, Mike, and thanks for all the good questions and comments. With that, let's move on to part 4. So we're still talking about keeping vehicles on the roadway, but now we're going to look at pavement and geometric techniques for doing that. So here our learning outcomes would be to describe countermeasures that reduce the potential for vehicles leaving the roadway or crossing the center line, and that can be applied at low cost and in short time frame. But if you think about it, since we're talking about pavements and geometry, not all of these solutions are going to be low cost, kind of quick fix things. Some of them may be higher cost and longer term. And I think I showed this slide yesterday just to orient you. We've been talking about marking and delineation and signage for keeping vehicles on the roadway. Now we're going to look at rumble strips, revising median widths and super elevation, which are design kind of issues, geometric issues. And then we'll look a little bit at friction, skid resistance, and high friction surfaces. Rumble strips, and here we're talking about longitudinal or shoulder rumble strips installed along the edge of the roadway. These have been around for a number of years and probably are one of the more cost-effective safety treatments in terms of reducing or addressing roadway departure crashes. And there are quite a number of resources available on this topic. Here are a couple examples. Federal Highway Administration has issued technical advisories on both shoulder and edge line rumble strips and center line rumble strips. So let's look at these in a little bit more detail. The rumble strips are intended to address similar crashes as pavement markings, especially when the roadway departure is a result of a distracted or drowsy driver. That going over the rumble strip creates a noise. It also creates a vibration. And so it's intended to get the attention of the driver, especially the distracted or sleepy driver. This was probably the original type of shoulder rumble strip, the rolled rumble strip. The steel strips were put on the roller as it went along the shoulder here, creating the rumble strip. And these were okay, I guess. Maybe they did wear out more readily than the current design. They were not certainly, as I'll call it, aggressive in terms of the noise or vibration. So we've tended to go away from that. And now pretty much the common design that's used are the milled rumble strips like you see here. They have more noise, I think more vibration than the rolled rumble strips. There are also these raised markings that I talked about yesterday. I think I called them cookies and biscuits, that not quite as pronounced an effect as the milled rumble strips, but when a vehicle passes over these, there is a noticeable effect for the motorist. But as I think I mentioned yesterday, we tend not to use these in snow country because you can see they're very susceptible to snowplow damage. And here's various types of designs. Rolled versus milled rumbles. Virginia DOT a few years ago did an interesting study on why milled rumbles work better than rolled, and some interesting findings. Notice that the tire drops about 10 times deeper into the milled rumble strip, and they produced about 335% more noise and 1,260% more vibration than the rolled rumbles. And the normal depth of 1/2 to 5/8 of an inch and 7 inches across the gap, as you see here. Rumble strip placement on the shoulder. There's a variety of ways of placing the rumble strip. A more recent development is what's called the rumble stripe, where you place the edge line or the center line right over the milled portion. And that does several things. Number one, notice it puts some paint down in the milled portion, which is lower than the pavement elevation. And so it's protected from the wear of tires. Maybe in our part of the country where many of us are, more importantly, maybe it protects the marking from snowplow blades, damage from snowplows. And so even if the line itself that's on the unmilled portion of the pavement, even if that wears out, you still have some paint down below in the milled portion. And so you should have some visibility and delineation at night. Here you see, I would call this a centerline rumble stripe. Notice we have the rumble strip in the center of the roadway and then the pavement marking on top of that. There has been quite a bit of research on rumble strips, longitudinal rumble strips. Here you see some data on the shoulder rumble strips. I should probably explain a few of the acronyms here. SVROR is single vehicle run off the road crashes, which of course is the type of crash that the rumble strips really are intended to address. And the SE is the standard error associated with the research. So you can see on rural freeways, 11% reduction in single vehicle run off the road crashes, 16% reduction in single vehicle run off the road fatal and injury crashes. FI is fatal and injury. And you can see a little bit higher crash reduction on rural 2-lane roads. Some research done by Federal Highway Administration a few years ago found that on rural freeways, rumble strips placed closer to the edge line are more effective at reducing single vehicle run off the road fatal and injury crashes than rumble strips placed farther from the edge line. But interestingly, they found that on rural 2-lane roads, there's no difference. In other words, where the rumble strip is placed, whether close to the edge line or at the back of the shoulder, it doesn't really matter on rural 2-lane roadways. And here's some advisory from FHWA in terms of rumble strip dimensions. And one recommended practice, especially for bicycles, as we'll talk about, bikes are one of the issues when it comes to rumble strips, is put a 12 to 15 foot gap every 40 to 60 feet along the roadway. And that allows the bicyclist to be able to move between the shoulder and the traveled way. Rumble strips can be an issue, a control issue, an injury, crash and injury issue for bicyclists. Another issue is the milled rumble dimensions. And I always get confused here, but when they say length of rumble, they're talking about what I would call the lateral dimension. That's what they refer to as the length. So as you saw, back up here a minute, as you saw, I think in these examples, here you're talking about this is probably 12 to 16 inch length of rumble strip along this 2-lane roadway. That's in Mississippi. And there's also lengths of 8 to 12 inches. There's been interest in recent years in a number of jurisdictions around the country on what they call narrow rumbles, or some people call them skinny rumbles, like you see here. So this is, I'm not sure that's 4, maybe 6 inches, but 4 or 6 inch long rumbles have been tried. Especially, these would be appropriate maybe for, like you see here, a relatively narrow 2-lane rural road. Preliminary results suggest, it's not as effective maybe as the conventional length rumble, but it does provide some benefit and may also be less intrusive in terms of its effect on bicycles. So I think there's still some research underway investigating those narrow rumbles right now. I mentioned the rumble stripes. Here you see this is a research project. You wouldn't have the normal edge line and the rumble stripe, but this was a research project. And this is in the rain in Michigan. Notice the normal conventional painted edge line, not very bright or not very visible, but notice the rumble stripe. You can see, as I mentioned, we're in the lower area where the material is protected from traffic and from snowplow blades. You get, it retains its properties of retroreflectivity. So the rumble edge stripe is very visible. And this is also from Michigan. This is a dry condition photograph after one winter, but I think you can see here on the left, the normal edge line, you can see significant wear and damage. Much of that's probably due to snowplow blades, but notice that the rumble stripe here is still in relatively good condition, at least in terms of providing visibility for the motorist. Mississippi's looked at several different size rumble strips and striping patterns. You can see 6, 9, 12, 16. And here you see the 12-inch rumble stripe and the 6-inch, the more narrow rumble stripe we talked about. This concept can also be applied, as we indicated, for centerline situations. Here's again, I'd probably call this a centerline rumble stripe. It looks like the paint has been painted over the milled portion. There has been some work done on looking at the safety effectiveness of centerline rumble strips. This data here is for rural 2-lane roads, traffic volumes 5,000 to 22,000 vehicles per day. And you can see the crash types for all crashes, all injury crashes, opposite direction crashes, opposite direction injury crashes, and CMFs range from 0.75 to 0.86. Here you see some more data for urban versus rural, a variety of different crash types and severities. And you can see the CMFs pretty wide ranging here. Notice the second line there, the CMF is 0.36, which would be a 64% crash reduction, pretty significant, but also notice it has a high standard error. Maybe that was a small sample size study, but you can see again vary quite a bit from 0.36 I mentioned to 0.6, 0.7, even 0.91, so which would be a 9% crash reduction factor. Variety of different practices depending on the agency. I'm not sure which state this is, but notice I would call this a rumble stripe. The striping is kind of superimposed on the milled rumble strip. Top here we see a centerline rumble strip milled across the marking, similar to what we just looked at. Middle photo there, you see the rumble strips on either side of the pavement markings. And then in the bottom image there, you see, I'd call that a rumble stripe again, with variable spacing of the rumbles. The MUTCD also addresses this, and notice they have a standard that an edge line shall not be used in addition to a rumble stripe that's located along a shoulder. I showed you that a few slides back, but those images were part of a research study in Michigan. We would not do that in normal practice. And here you see, this is, I believe, Washington State. Notice they call this a bicycle-friendly shoulder rumble strip. There's gaps to allow the bicyclist to move between the shoulder and the traveled way. And also you have a centerline rumble stripe. And notice the practice of the placement here. There is sufficient shoulder width behind the rumble strip to accommodate bicyclists. I've sometimes seen agency might put the rumble strip right in the middle of the shoulder, which may make it unusable for bicyclists. So think about bicyclists when you're positioning the rumble strip. And remember, in rural areas, research shows that on rural 2-lane roads, I should say, rural 2-lane roads, the rumble strip could be right at the edge line here, or it could be at the back of the shoulder. Texas DOT and Federal Highway Administration have also looked at effects of shoulder and centerline rumble strips. This is on 2-lane undivided roadways. Notice centerline rumble strips had no adverse impacts on lanes as narrow as 10 feet, but actually helped center the vehicle in the lane. So there's also effects on lateral positioning of vehicles. Centerline rumble strips and edgeline rumble strips had no adverse impact on lanes as narrow as 11 feet, but again, actually helped center the vehicle in the lane. Shoulder rumble strips placed within 9 inches of the edge line stripe on 12-foot lanes may cause vehicles to move to the left. So it does affect their lateral placement in that situation. There are a number of issues associated with rumble strips. I've mentioned bicycles. Another one is motorcycles. How do these rumble strips affect motorcycles? Another is kind of the pavement situation, pavement thickness, the joint type of joints, those sort of things. How is that affected by rumble strips? And then in built up areas where you have homes and businesses near the road or street, there is a concern with noise. So let's look briefly at each of these. With bikes, I think I've talked about some of these already. These are some of the questions that agencies have regarding bicycles and rumble strips. And I talked about having a gap or periodic gaps in the rumbles to allow bicyclists to move between the shoulder and the traveled way. Some agencies use shallower rumbles, like 3/8 inch deep versus the 5/8 inch that I talked about earlier. And they consider those to be an acceptable compromise. I mentioned motorcyclists. Over the years, I have heard reports too from motorcyclists or safety folks about the maybe potentially adverse effect of especially centerline rumble strips on motorcyclists. So the Minnesota DOT a few years ago did a pretty extensive study looking at the effects of centerline rumble strips on motorcyclists. They reviewed the crash history of locations with centerline rumble strips. So they actually looked at police crash reports where motorcycles had reported crashes and where the roadway had a centerline rumble strip. They also reviewed 44 hours of direct and video recordings of locations with centerline rumble strips. So they actually observed drivers on these roadways, or they viewed the video which had been taken. And then, as you may be aware, Minnesota has a very good test road facility. I think it's outside of Minneapolis, where they use it mainly for things like pavement design and that sort of thing. But in this case, they set up a closed course on their test roadway, and they included centerline rumble strips as part of this test course. So you can see it was pretty comprehensive. And these are a quick summary of their findings. Of the crash reports that they looked at, and they looked at, you can see almost 10,000 motorcycle crash reports on these 2-lane roads with centerline rumble strips, but 0 of those mentioned the centerline rumble strip, meaning in the police narrative or police reporting of the crash, there was no mention of the centerline rumble strip. Their observation, direct observation and video observation, showed a small number of rumble strip crossings, but there was no instance of directional change or unusual riding behavior. So the researchers concluded that the centerline rumble strip did not seem to inhibit any passing opportunities. And the closed course examination, and they actually interviewed the operators after their run through the closed course, confirmed that there was no steering, braking, or throttle adjustments during the rumble strip crossings, and no rider expressed difficulty or concern with crossing the rumble strip. So it seems like many of those concerns, at least that have been expressed, maybe are non-issues, at least according to this Minnesota study. There are a number of pavement issues, pavement thickness that's needed. What about the effect of the rumble strips on joints, pavement joints? How do you handle Portland cement concrete pavements? What do you do with chip seal pavements? So some agencies do have a minimum thickness for the pavement thickness for the use of milled rumbles. There are some techniques that have been used over the years to try to improve joint performance, maybe using wedge joints or properly compacting the joint, those sorts of things. And some states have milled in the rumbles on Portland cement concrete pavements. Here you see I-96 in Michigan. This would be, I guess, the original rumble that was built into the shoulder. These were periodically spaced. Of course, there were gaps between them. And so it looks like here they actually milled in a shoulder rumble strip. So that's continuous along the edge line of the roadway. Here you see a couple examples on the left. This is in Michigan. They installed the rumble strip over the chip seal. And in the right image, this is Washington State. The chip seal was applied over the rumble strip. Some states require fog seals when doing the milling. It's not clear if that's necessary. And keep in mind that that fog seal may not mix well with thermoplastic pavement markings. The other issue with the rumble strips is the noise. Now, it needs to be loud enough, of course, to get the attention of the motorists, but at the same time, then that noise can interfere maybe with the activities of commercial and residential entities along the roadway. PennDOT a few years ago developed a noise model, and there was no definitive threshold for minimum stimuli levels needed to be generated by rumble strips to be effective. But one source reported that sound level changes above 15 dBA could produce a startle reaction on the part of the vehicle operator, which would not be desirable. These are some of the factors that affect the noise produced inside the vehicle by rumble strips. You can see the depth, the width, the length, spacing, and of course the speed of the vehicle. Complaints may be made by nearby residents, and so what some agencies do is actually discontinue the use of the shoulder rumble strips or the centerline rumble strips in residential areas. So you see down here on the left, notice I wouldn't call this, this is probably not a town or city in that sense, is maybe I'd call it a built up area or unincorporated area, but notice there are residences or businesses close to the road. So some agencies, some road agencies would probably discontinue the use of shoulder rumble strips through an area like this because of the potential noise issues. So those were rumble strips. Another, that would be a pavement method for keeping vehicles on the road. If we switch to the geometric techniques, one way is to revise the widths of the medians to help keep vehicles on the road or keep vehicles within their lane. And the crash types addressed by doing this would be, of course, all roadway departure crashes, but also head-on crashes as vehicles depart their lane. Here you see some examples. Again, it's probably going to be agency specific. You can see a variety of different marking patterns, but notice the common idea is to allow maybe 2 or 3 kind of feet additional separation between opposing traffic streams. Here you looks down here in the lower left, it looks like a rumble stripe configuration. Same thing here in the lower right. But again, each agency has slightly different practices. this is interesting. This is some results from South Australia, in Australia, and it looks like they are using those kind of enhanced pavement markings, the biscuits or the cookies that we talked about yesterday. And I should note, in this part of Australia, they don't have to worry about snow or ice, so snow plows are not an issue. Again, this type of marking would be an issue in many areas of the northern United States where snow plowing is common. The other thing I should note is that this is a 2-lane undivided roadway, but in Australia, as in many countries, they do not use yellow for their center line markings. They use white. So of course, in the United States, these would need to be yellow markings. But you can see they claim they have found significant reduction in head-on crashes, run off the road left crashes, and total severe crashes on the roadway just by, you can see what's that, maybe 3 feet, 3.5 feet or so width within the median there to separate the opposing directions of traffic. Another technique that some agencies use, including where I live, the West Virginia DOT, uses curve widening, or widening the insides of curves. And one of the issues, and with our hills here in West Virginia, of course, we have a lot of winding roads. The pavement widths may be relatively narrow. And so in some of these sharp curves where you have significant commercial vehicle traffic, truck traffic, the rear wheels of the truck, of course, off track, like you see in the graphic there. And so those rear wheels may go off the road onto the shoulder or the road side. And what happens over time is, as those wheels go on the shoulder or the roadside here, they remove or kick out some of the shoulder material, causing the shoulder elevation to become lower and actually creating an edge of pavement drop-off condition here, which is a safety issue. But another safety issue created by this phenomenon is that the loose material, stone and so forth, from the shoulder may end up on the pavement. And then you have loose material in a curve, which of course is not a good condition, not a good situation for two-wheeled users, namely motorcycles and bicyclists that might be on the road. So what our DOT, and they've been doing it for a number of decades now, is they will put a crescent-shaped area of asphalt here to kind of widen the inside of the curve. This is not West Virginia, but, and most of ours are not quite this wide, but you can see, notice this, there's that crescent-shaped area of asphalt on the inside of the curve to allow for the off-tracking of larger vehicles as they go around the curve. And actually there is some crash reduction data available for this. You can see a 40% crash reduction for a 6-foot wide shoulder in terms of reducing run off the road crashes. I'm not sure what the crash reduction factor would be for, say, the West Virginia DOT. We typically don't provide 6 feet of a shoulder here. It might be, you know, a couple or 2.5 feet or so, basically the area that you see worn down here by the tire tracks. But this is a low cost kind of geometric improvement that can be made to enhance safety, reduce roadway departures, eliminates the edge drop-off problem, also reduces the amount of loose material that's on the pavement. And you can see, I guess it can be also used by smaller wheelbase vehicles to kind of cut the corner short there. Another geometric technique is to improve or restore super elevation, the banking of the curve. But I want to emphasize this is certainly not a low-cost safety improvement. You may be rebuilding the curve itself, and so this is, as the slide says, moderate to high cost potentially. But it is a proven treatment that by banking the curve, you counteract the lateral forces imposed on the vehicle as it negotiates the curve, and so it certainly does have a good crash reduction results, in my opinion. Because I think it's been demonstrated curves with inadequate super elevation can and do pose safety problems, especially maybe during wet weather when you get water ponding on the roadway. Many vehicles have inadequate super elevation because vehicles tend to travel at higher speeds than the roads were originally designed for. You may lose some effective super elevation after resurfacing, and there may be changes in design policy after the curve was originally constructed. With regard to super elevation, some other issues to consider. If you do increase the super elevation, be sure to pay attention to the slope break between the elevated edge of the pavement and the adjacent shoulder, and limit that. In fact, the AASHTO Green Book design criteria gives some specific guidance in that regard. But what can happen if that grade break is too great, when you get a high center of gravity vehicle like a truck or a bus moving from the roadway onto the shoulder, the vehicle can actually overturn if that grade break is too severe. And also pay attention to when you're transitioning from the normal crown to its full super elevation in the curve, which is done usually by rotation. Need to make sure that rotation is done over sufficient length so that the actual rotation's imperceptible to drivers. But recognize too that combination of longitudinal profile and super elevation does produce or can produce some unintended flat spots along the roadway, which during rain events you may get water ponded there and you could have hydroplaning issues.
Hey, Ron.
Yeah.
Hi. So we've had a few questions come in based on the recent slides, and you've already basically answered some of these, but question from Atif, what should be the minimum width of shoulder where we can place edge line / narrow rumble stripes?
Oh, great question. And I guess the question was specifically the narrow rumble strips. Let me see if I can back up here. I apologize. I'm going to find that image. Not sure I've seen guidance yet, because there's, as I mentioned, there's still studies underway about the narrow or the skinny rumbles. But just my advice, and I think this is Pennsylvania, but my advice would be maybe something like what we see here. And what is that? Maybe 2.5 feet, 2 to 3 feet would be probably my suggestion at this point. But that's kind of just my gut feeling based on experience. I don't have any actual kind of research data to back that up, but that would be kind of my thought or suggestion.
Thanks, Ron. Kessa was asking if you are able to talk any more about use of centerline rumbles in urban areas.
Yeah, good question. And I don't really have any data on that, but I guess where I've seen it is more in what I would call the built-up areas along a roadway. I don't know that it was actually an incorporated community or what I'd call an urban area, but as I mentioned, some agencies will just sort of stop using the center line rumbles in those applications because of the noise issue. My own thought is I would probably look at each specific situation. If it's an urban arterial that maybe, for several blocks or whatever, is more of a, what would you say, kind of like a warehousing district or commercial industrial district, where you may have limited or no residential population there, it would seem like you could go with the centerline rumble strips. Whereas if the roadway was passing through residential area or maybe retail area, I may not want to put the centerline rumble strips in that situation because of the noise concern. So I'd probably want to look at it on sort of a site-by-site basis, depending on the context. Those would be my thoughts.
Thanks, Ron. Regarding the previous question from Atif, Bridget says, quote, 2 foot in ODOT guidance on the edge line / rumble strips, see 1415-3.2 in the traffic engineering manual. Edge line rumble stripes require a shoulder width 2 feet or greater, end quote. So thank you, Bridget.
Yeah, thanks, Bridget, for that resource and then that advice. Thank you.
Egan says, could you say a little bit more about fog seals? He's not sure what that refers to.
Yeah, let me see if I can find that. It would be an application of an material like an emulsion or asphaltic material. I'm not real familiar with it either. For example, the agencies where I do most of my driving, Pennsylvania or West Virginia, typically do not apply the fog seals, but I have seen it. Last summer I was driving down to the Richmond, Virginia area, and I noticed on Interstate 64 through Central Virginia, they seem to have tens of miles of wherever there was a milled rumble strip. I assume it was a fog seal. It was some type of emulsion or material, asphaltic material applied on the rumble strip. And I assume that was there to maybe enhance the performance or to reduce the maintenance requirement of the rumble strip. But again, it's not something that's universally done. I don't know if ODOT has any sort of guidance or specification in that regard, but it is an attempt, I believe, to try to improve the life and performance of the milled rumble strips on asphaltic pavements. I don't know if anybody that's with us can speak to the effectiveness of it. Unfortunately, I wish I had a better answer. I don't have any data or information on the effectiveness of how well this works.
Thanks, Ron. Michael just says a fog seal is a low-cost asphalt preservation treatment, applying a light mist of diluted asphalt emulsion to renew old surfaces, seal minor cracks, stop raveling, aggregate loss, etc. So I'm sure there's more information online.
Yeah, thank you for that. And it probably also depends on, as I talked about earlier, how thick the pavement is, the age of the pavement, those sorts of things in terms of how effective those fog seals will be.
Thanks, Ron. Steven says a town close to him uses rumble strips on a county road lane to help slow down vehicles before the stop sign. Is this a common practice in other areas?
So it sounds like you're talking about the transverse rumble strips, I would call them, which are at right angles to the direction of travel. And they often are used maybe in pairs or in triplets, approaching maybe a stop sign or approaching a sharp curve. They could be milled into the pavement, or they could be created by using pavement marking materials to a greater thickness than you'd normally use. And I don't know if I'd say they're common, but no, a variety of agencies do use those on approaches to, as I said, intersections or curves, probably maybe even school zones. I think I may have seen or gone through one this summer. But yes, it is a method. I think it's or even maybe before work zones, for example, entering work zones where you may have a maybe a lane closure or reduction in lane width or something, and you want to get motorists' attention. That's another place where those transverse rumble strips might be used. I think it's generally effective. Again, the main concern, I think, would be if it's in a built up or residential type area, the main concern would be complaints from residents about noise.
All right, thanks, Ron. Regarding the slides about widening of the pavement on the inside of curves, Kessa says for CRF purposes, is that crescent area just considered a shoulder widening, or is it something separate when isolated at curves?
Yeah, that's a great question. That's a great question. I think I'd want to think about that. But yeah, that's a good question. I don't have an answer off the top of my head, unfortunately. I apologize.
All right, thanks. Oh, go ahead.
Points up a good question with with the CMFs and CRFs. It's important sort of how these are defined and make sure we're all talking about the same thing in terms of the research and then implementing or using those effectiveness values.
All right, thanks everyone for your questions and comments. We appreciate that.
Yeah, thanks, Mike, and thanks everyone for great questions. So now we're going to switch gears a little bit from the geometry and talk about friction, pavement friction, and providing skid-resistant pavement surfaces. Again, we're still talking about reducing the likelihood of a vehicle leaving its lane and either departing the roadway or crossing the center line. Skid-resistant pavement surfaces have been of interest for decades. This is one of, I guess, the original highway safety program standards back probably in the 1970s, talked about the importance of providing high skid resistance qualities on pavements, and that states, when they're doing their resurfacing programs, should emphasize correcting locations with low skid resistance. So the relationship between skid resistance and safety has been recognized and emphasized for many decades. In fact, the Code of Federal Regulations says pavements shall be designed to accommodate current and predicted traffic needs in a safe, durable, cost-effective manner. And that may be mostly referring to, for example, pavement thickness. But to provide a safe pavement, we also need to provide adequate wet pavement friction. Here is a kind of a conceptual plot of pavement friction versus crash risk. So on the vertical axis, we have crash rates, crashes per 100 million vehicle kilometers in this case. And on the horizontal axis, we have skid resistance running from 0.3 to 0.6 and then beyond. And notice that this would be the crash risk here. Notice how it decreases as pavement friction increases. And in fact, if you look closely at that, if we double the skid resistance, we cut the crash rate in half. So obviously this is important. Friction is important. And just to give you maybe some perspective here about these skid numbers or coefficients of friction, and of course it's going to vary with the type of pavement, the nature of the mix, asphalt mix, and a number of other things, concrete mix, but probably a typical new pavement, new asphalt or concrete pavement, is probably going to have a friction value or skid resistance maybe of 0.6 to 0.7. So a new pavement is going to be up here in this range. And then of course over time, due to wear, traffic wear and weathering and so forth, that skid resistance is going to deteriorate or reduce. And some agencies talk about a skid number of 40 or 0.4 when maybe the friction value reaches about this level, they will say it's necessary to resurface the pavement from a skid resistance standpoint. And we talked yesterday about icy pavement. I think we'll talk here in a little bit about bleeding pavement, another type of pavement issue. And an icy pavement, and obviously ice and snow is going to depend on a lot of different things, the moisture, the temperature, the humidity, and so forth. But an icy pavement, snow-covered pavement, could be as low as 0.1 to 0.2. So they're going to be those conditions, which of course occurred mainly only during sort of certain weather events, but those conditions are going to be way down here in this range. Federal Highway Administration provides some guidance on friction, surface texture, pavement friction management. Skid-related crashes are determined by many factors: the geometry of the road, the curve, the grade, the vehicle speeds, the tires, tire tread pattern, tire inflation, pressure, just the tire design and construction, driver actions in terms of driver braking and steering, weather conditions, of course, rain, snow, different temperature conditions, traffic characteristics in terms of the mix of vehicles, passenger type vehicles versus trucks versus buses, and then pavement surface condition and drainage in terms of the maybe propensity for water to pond on the pavement, or how quickly can water drain off the pavement. So all of these things influence skid-related crashes. This is my list of some problematic, as I call it, problematic road surface conditions that could lead to roadway departures. Ponded or excess water on the pavement where a vehicle may hydroplane. Snow or ice covered pavements, as we just talked about. Mud or other contaminants on the surface may reduce the ability of the driver to control the vehicle if the road is mud covered. We'll talk briefly about, when we talked about the widening the inside of the curve, loose stones or other material on the surface can affect the friction. Bleeding pavement, I mentioned that. If you're not familiar with that, we'll talk about what that is. Polished pavement, certain types of limestone aggregates are susceptible to polishing, meaning they become very smooth under traffic wear, and when that's wet, that becomes a slippery pavement. Could have rutted pavement, and older pavement or maybe certain types of pavement types may be susceptible to rutting. And we could have a rough surface where the vehicle sort of bouncing on the roadway, and that affects the friction. So let's look at some of these. Excess water on the pavement. To me, the number one rule, and those of you who are engineers probably heard this in your classes from your professors, but drainage affects the performance of the pavement in terms of its life, but also drainage is related to safety. Number one rule would be to get water off the pavement and keep it off the pavement, not direct water onto the pavement. But notice here we have maybe an inadequate ditch, and here in the curve the water is flowing across or down the super elevation, actually across the roadway, creating looks like much of the road is damp or dry, but here there's significant water creating a hydroplane potential. But also notice, and the volume of water looks like it's reduced now compared to what it was earlier, but notice the water was also washing some small stones or other material sediment onto the roadway, which when the water dries up or disappears, you're still going to have loose materials in the curve, which, as we've talked about, affects safety or vehicle operation. Water on the road due to a high shoulder. This is a relatively common maintenance issue. High shoulder means, notice this grass or turf buildup here prevents the water on the roadway from running off. There looks like there is a ditch here, but the water can't reach it because of this high shoulder. And so this, again, could lead to differential friction issues two sets of wheels. The right wheels are on water. The left wheels might be on dry pavement, and that can affect performance. The vehicle could tend to rotate. Same thing in the wintertime. That water freezes. You have two wheels on ice, two wheels on dry pavement can affect control of the vehicle and potentially lead to roadway departures. The correction, of course, is relatively simple. Get maybe a motor grader in here and just blade that high material off so that the water can flow off the road onto the into the ditch. Snow and ice covered pavements generally are an issue, but that's why we, of course, plow and treat roadways. So hopefully after the storm is over, we can have bare pavement with better friction properties. But during times of snow and ice and related events, the pavement will have reduced friction properties. And then there's what the attorneys call isolated icing condition, which can be particularly an issue both from a safety standpoint and from a legal liability standpoint. You know, I guess you could argue when there's a general snowstorm like we had in probably Ohio, West Virginia, Pennsylvania last weekend, motorists are aware because it's snowing heavily, the pavement is snow covered, motorists are aware of hopefully aware of the reduced friction and the pavement condition. But these isolated icing conditions can be particularly troublesome from a safety standpoint, because as you can see here, most of the road was dry on the day of this crash, but due to a unpermitted driveway, improperly designed driveway, notice runoff water was directed actually onto the roadway where it froze and created what the personal injury attorneys call an isolated icing condition. And because they're unexpected, that's one of the main reasons why they're so troublesome, because they can catch drivers unaware. But certainly the friction in this area due to the icing would be much less than it was on the rest of the roadway. Mud on the pavement can be particularly troublesome, especially when it gets wet, can create a slippery pavement condition. This is an example of bleeding pavement. The insert here shows, notice an excess of asphalt at the surface of the pavement. And when the pavement is dry, like you see here, this is not really an issue. But what happens when a bleeding pavement gets wet during a rain event, this excess of asphalt here in combination with the water creates a very slippery condition. In fact, studies show that the friction levels can reach those associated with snow and ice conditions, a very slippery condition. And so we need to be attentive to bleeding pavements, especially in areas where there's high friction demand. And this scene shows two areas, in my opinion, of high friction demand. Notice on the approach to this curve, motorists will need to be slowing down for the curve, and so that's a need. They have a need for braking friction, and then we can't see much of the curve, but when they're in the curve, there's a need for friction to be able to steer, the lateral friction to be able to steer around the curve. And if this is bleeding pavement, and we can see some bleeding pavement here, that's a concern, because I suspect this curve probably has a high wet weather crash experience. But also notice it appears there's really no advance warning for this curve. There's no, I don't really see any, like even an arrow, a left arrow or chevrons or anything like that to help motorists navigate that curve. Polished and or rutted Portland cement concrete pavement. This is near the Pittsburgh area, but an old, very old concrete pavement, but just due to traffic wear and studded tire use during the winter time, notice we have significant ruts that have been worn into this pavement. And what happens is during rain events, these ruts can fill up with water and create a hydroplaning potential or a differential friction condition, which presents safety issues and tends to increase the roadway departures. And then a rough unpaved surface, like you see here, this would be a good example of washboarding on a gravel road. Notice that rough surface, the vehicle sort of bounces along, not always in contact with the surface, and that will have a lower friction level than a smoother surface would. So improving friction is key to keeping vehicles on the roadway, and there is plenty of guidance available from a variety of different sources. Here's a National Cooperative Highway Research Program report guide for pavement friction. Number of factors, of course, come into play. For example, water film thickness. So this is sort of a different plot than we looked at before. In this case, friction is on the vertical scale, and the water film thickness, getting thicker as we move to the right, is on the horizontal scale. And notice we're looking at 3 different types or categories of tires. The heavy black line with the black diamond is a worn ribbed tire. The gray with the gray rectangle is a new ribbed tire, and the dashed line with the open triangle is a smooth tire. So notice at the thin water film thicknesses, there's not much water on the pavement. Notice actually the smooth tire has the higher friction, but then as we go to thicker water films, of course, that friction drops off very rapidly to a very low value down here. Whereas for a worn rib tire, notice friction level starts out lower, but it doesn't drop off nearly as rapidly. Or for the new rib tire, starts relatively high, but then drops off and then kind of levels off. And of course, really a smooth tire would probably be best from a friction standpoint on dry pavement. For race cars, have smooth tires, but then when the rain falls, then they have to suspend the racing until the racetrack is dried again. And obviously on public highways, we don't have the luxury of closing the roadway when the pavement is wet. So the roadway has to accommodate traffic under wet and dry conditions, which is why we use the treaded tires. Talking about curves and navigating curves and lateral friction on curves, the curve design that's used in highway design, that model is based on driver comfort. And of course, as comfort increases, speed increases as well. And that's an issue because at high speeds that we may have loss of control issues in the curve. I believe I mentioned yesterday when we were talking about how to determine advisory speeds for curves. I listed several different methods, and one of them was the curve design model. And I think I said I'd talk more about it today. This is the curve design model. I don't want to get into all the details of it, but you can see design of a curve is influenced by the banking or the super elevation of the curve, the lateral friction, the design speed of the roadway, and the radius of the curve. And so if we were going to use this method to determine the advisory speed for a curve, in that case, we could know from the plans, or we could measure in the field the super elevation. We could determine the friction factor. And again, the radius of the curve we could determine from the plans, or if the road was never really designed, we could go out on the roadway and measure that radius and then use this equation, knowing super elevation, friction, and radius, and we could solve it for V, the speed, advisory speed for the curve. In that model, though, AASHTO assumes several things. They assume that vehicles do not exceed the design speed, which of course is not always true. And they assume that the driver traverses the curve following constant radius, which of course, if you've ever observed the vehicle, say in front of you going around a curve, you've probably seen that that is not always true either. Sometimes drivers are traversing a curve sharper than the actual radius. Sometimes they may be traversing a curve flatter than the actual radius. And when these assumptions are violated, that's when the likelihood of skidding in the curve occurs. So how can we use friction to benefit safety, or what are the priority areas where friction is most important? It would be the things we've talked about: horizontal curves, approaches to intersections where drivers will be braking significantly, and then grades, especially downgrades, where drivers will be braking. So these are kind of the priority areas when it comes to providing good skid resistance, good pavement friction. Here is the conceptual diagram that shows the relationship between friction, demand, and speed and friction availability. So notice on our horizontal axis here, we have speed of the vehicle increasing as we move to the right. A vertical scale is tire pavement friction. So this curve here that starts on the far left, and you can see curves downward as you go to the right, that's called the friction supply curve, or the pavement tire friction capability. And of course, you may remember from physics, as speed increases, the frictional capability decreases, and that's what you're seeing here. The plot that starts down here and runs toward the upper right, this is called the friction demand curve. So as speeds increase, drivers or the vehicles demand more friction to be able to control their vehicle. And so notice at this point where those two curves intersect, that's called the speed of impending skid, because beyond that point to the right here, the friction demand exceeds the friction available on the pavement, and so a skid is impending, or a skid is likely. So of course we want to keep the friction demand below the friction supply curve to enhance safety on the roadway. But again, the things that we talked about, sharp braking for an intersection or on a grade, or lateral friction going around a sharp curve, all increase the friction demand as speed increases. And so it may be difficult to keep that friction demand below the friction supply curve. Something else to keep in mind is that that margin of safety against skidding on curves is defined as the difference between the available tire pavement friction and the friction demand of the vehicle as it tracks the curve. And commercial vehicles have different friction properties compared to passenger type vehicles. And this just shows the speeds on curves, driver behavior versus the model assumptions. And when FHWA looked at speed-related crash, their typology study, they found that speeding was the leading cause of single vehicle right or left roadside departures with traction loss, and the third leading cause of head-on crashes. And this was primarily on curves at night and on local or collector roadways during clear weather. I mentioned trucks. With their higher center of gravity, they will generally overturn in a curve before they lose control due to skidding. But skidding trucks also can lead to to overturn. Trucks on downgrade curves generate greater lateral friction. So super elevation is not as effective for trucks as it is for automobiles. And the margin of safety for that friction is lower for trucks. Another thing about trucks is that the friction demand varies per tire. Trucks generate friction demands about 10% higher than passenger cars when they're traversing a curve. And interestingly, the tire pavement friction for truck tires have coefficients of friction that are only about 70% of passenger car tires. So this is an area that has been studied. You can see here's a transportation research record addressing curve severity and design consistency using energy and friction-based measures. Common methods for adding or restoring friction, chip seals, micro milling, shot blasting. On Portland cement concrete pavements, we can use grooving, or we can resurface with a friction course, like Nova chip or high friction surface treatment, which is a spot improvement technique. This is some results from Long Island, New York. They treated 36 sites with providing a skid resistant surface, and they had a reduction of more than 800 annually recurring wet road crashes. You can see they improved the skid resistance at locations with high wet road crash frequencies, and they were able to reduce 50% for wet road crashes, 20% for total crashes. So what is a high friction surface treatment, HFST? This is one of Federal Highway Administration's proven safety countermeasures. It's a pavement surface overlay system. It's intended as a spot improvement, not over many miles of roadway. It's a spot improvement for, say, curves or bridges. And what it does is provide, as we'll see here in a minute, provides exceptional skid resistance properties that are not typically found in conventional aggregate materials. And also, this material is durable, so it retains those high friction properties for a longer time. And that those aggregates are applied to a resin-based product, which is also applied to the pavement. And it's a good way of significantly increasing available friction in areas where you have critical friction demand. So here's the aggregates, some of them, flint or bauxite or granite. You can see the typical size there. And then the binder material is usually proprietary blends of different epoxy resins. They can be applied manually, kind of using a squeegee, for example, how some commercial agencies, you've all probably seen how they might apply sealant to a parking lot or a strip mall or something like that. That's the manual method. But there's also the automated or machine-aided method. And here you see both. Notice here on the upper left, you see the manual application, a crew is applying it. And then here on the right, you see the automated or mechanical method. These are all scenes from West Virginia. You can see West Virginia DOT uses it in curves, especially where you might have, like, this is in the mountainous areas. It's an area that this time of year, for example, may be prone to frost on the pavement, that sort of thing. And they have found this to be an effective way to address that. They also use it on certain bridge decks, maybe curving or bridge decks on a significant gradient. And you can see the skid resistance values range from the low 70s to the high 80s. So again, these are much higher than the skid resistance values you get with traditional aggregates. Here's an example from Eastern Pennsylvania. You can see they're applying it starting in the morning. They have their traffic control set up, and they are also using the manual method, applying the binder and then the aggregate on top of that. And by 2:30, they were basically done. It was swept dry and ready for traffic. And notice you can see a little bit difference in coloration between the normal hot mix asphalt and the high friction surface treatment, but I'm not sure the average motorist would really notice that in many cases. Again, here's another view. Here's Hamilton County, Ohio. Note again, it's a spot application. This case is just used around the curve or bridge decks. Can also be used, and a number of agencies are using it on approach to intersections where you have high braking friction demands. I mentioned the West Virginia DOT. They really have believe in this product. They even now use it on certain interstate curve. This was a section of interstate, had some kind of reverse curvature in it, and they applied this the high friction surface treatment, and you can see they're anticipating significant crash reduction, especially wet weather crash reductions. This, I believe, is a state road in Oldham, Kentucky. Had a significant crash problem, high publicity type crashes, and they applied the high friction surface treatment. You can see around the curve, and they had significant crash reductions. I won't say it's low cost, but since it is used for kind of spot treatments, we can say it's relatively low cost. And Kentucky Transportation Cabinet has used it at a number of locations as well. This is an example from Bellevue, Washington, north of Seattle. To me, this is where this approach really has greatest value. You can see from the sign here that there's a steep grade, there's a traffic signal at the bottom, there's also a curve. So this is sort of a perfect storm of friction demand, braking demand and steering demand. So we need to have good friction properties, and you can see just on this approach to the curve, the agency has installed the high friction surface treatment. So you have the curve is there, the grade, and also the potential need to stop at the traffic signal at the foot of the grade. So that, to me, that's kind of the textbook application of where the high friction surface treatment can provide good benefit. And here's one more view of that. Here is a test scenario from the United Kingdom. This is one of their motorways, I believe they call them, the high type roadway, high speed. And for this research project, they have in one of the shoulders here, along one of the shoulders, they have set up, this is granite high friction surface treatment, the reddish color. And what you're going to see is two vehicles. You can kind of see them there in the background. They are side by side. They're traveling, I believe, at 60 miles per hour, and they will brake more or less at the same time, and you'll be able to see the difference in stopping capability. So you can see what's that? The car on the high friction surface treatment stopped, what, maybe 1+ car lengths, maybe 20 feet shorter stopping distance than the car on the conventional hot mix asphalt pavement. So the material works both for braking friction and for lateral or steering friction. We do have some CMF values for the high friction surface treatment. You can see some of the values here and here as well, using for ramps and curved roadways. And to kind of wrap up this portion, I think we're right on time here. This is an example of a single vehicle roadway departure fatal crash in Pennsylvania. Actually, a tragic situation. It was a fatality. But to me, this shows how the roadway design or lack of it, signing and marking, and pavement surface condition deficiencies all kind of came together along with vehicle and driver characteristics to create this tragic outcome. So briefly, what happened here, we had a loaded water tanker that was carrying water for shale gas operation. The driver had driven trucks like this before, but his experience had always been in, I think, East Texas and Louisiana, so the terrain was relatively flat. Here he was in kind of the hills of Western Pennsylvania, and he'd never actually driven a truck like this in that sort of terrain. The driver had never been on this road before. Actually, he was lost. He was supposed to be on a different road. It had rained a few minutes before he arrived on the roadway, so the road surface was wet. There was some evidence of bleeding pavement, and it was a long and steep downgrade. So this is nearing the bottom of the grade. He'd been on the grade. You can see it's just, I would call this, in fact, in this part of Pennsylvania, they call this a tar and chip road. It's just a surface treatment roadway. It looks like at one time there was a center line on the roadway. It's pretty well worn out, I think, by now. But notice the road seems to get steeper as you go down. There is a yellow and black left arrow sign, but there was no advance warning sign, no advisory speed plaque. Now this is from the bottom looking up, and you can probably see one of the design issues. Notice for a driver coming toward us, this would be a left-hand curve. So to counteract the lateral forces, our left side of the road, the driver's right side, should be higher than the opposite side. But in this case, this is an example of reverse or adverse super elevation. So this roadway is banked the wrong way, and I think you can appreciate it will actually sort of facilitate a vehicle sliding off the road. It's hard to see, but there is some evidence of bleeding pavement, and as I mentioned, the pavement was wet at the time. And again, just kind of a perfect storm. The driver was probably going too fast for conditions, maybe not in the proper gear, not having experience driving a loaded truck in this type of terrain. There was no warning sign, and so the vehicle went out of control, overturned on the roadside, and the driver was fatally injured in the crash. And I think it shows kind of all of the things we've been talking about. There's some driver issues, some vehicular issues, roadway issues, maybe traffic control device issues, also some roadway design issues as well. So in the few minutes we have here, which of these locations might be a candidate for high friction surface treatment? And you can type your response in the chat. A, polished pavements, B, curves, C, wet weather crashes, D, lack of adequate super elevation, E, intersections, or F, all of the above. Any thoughts on that? And Mike will share some of the responses.
All right, thanks, Ron. It looks like there's an overwhelming agreement on option F.
Yeah, I agree. Yeah, all of those are good potential locations for high friction surface treatment. Thank you for that. So here we've looked at geometric and pavement countermeasures to help keep vehicles on the roadway. We may have a minute or two for questions if there are any.
Sure. Yep. Thanks, Ron. Kessa says, is she understanding correctly that trucks need more friction, but their tires provide less?
That's correct. Unfortunately, yes. Yes.
All right. Sandra says she's asking, do high friction treatments help prevent rutting in asphalt?
I would say no, because I'm not sure what the thickness is, but it's just more like a coating or overlay on the roadway. It doesn't provide any sort of structural strength or anything like that. So I would say it does not prevent rutting. And in fact, I'm not sure I mentioned it, but to me, that's one of the things you'd want to look at before you would invest in the high friction surface treatment, is make sure sort of your existing or underlying pavement is adequate and has some life with it. I wouldn't want to put this on, say, a badly cracked pavement or pavement that had, alligator cracking or that sort of thing, because this will not structurally do anything to the pavement. And since a pavement like that might wear out pretty quickly, it might not be a wise use of resources to apply it to that type of pavement.
Thanks, Ron. Question from Jeff. Do these surface treatments create any challenges regarding the application or effectiveness of pavement markings?
Oh, great question. Yeah, and I think they might. I don't have a lot of experience myself, but let me back up to this. Well, you notice here, and I'm not familiar with this project at all, but notice the HFST is, they did not cover the edge line. It looks like they did cover the center line. And also, well, same thing here. Notice it looks like they tried to leave the pavement markings, the original pavement markings. And I think also, well, no, here it looks like they did cover the pavement mark. I was going to say, I've seen some of our bridges in West Virginia, our DOT will kind of go right up to the edge of the pavement marking. So yeah, pavement markings would be an issue with this, and something you need to look into with this high friction surface treatment. And you can see some examples here where it looks like they intentionally do not cover the pavement markings and leave the existing pavement markings. So good question.
All right, well, thanks, Ron, again for presenting today, and thanks so much to our audience for their questions and comments. We greatly appreciate it. Tomorrow will be day 3 of 3 at 10 a.m. Eastern Time, and once again, each person will have a new link to join for tomorrow's broadcast. So thanks so much, and we'll see you then.
Yeah, thanks, Mike, and thanks, everyone. We'll see you tomorrow. Have a good evening.